Hello. Algebra students, Mr. Lawrence here, and I'm joined by Lammy Blue Bunny, and this time, Cloudy the little baby sheep. Anyway, at my kid's request, I don't know what I'm gonna do. I'm being overtaken by animals. Ah! Anyway, let's get down to business here. Today we're going to be talking about parallel and perpendicular lines. It seems like a small deviation, but that's okay. It's very similar stuff using skills that we have to have mastered to be able to solve our systems. So it's okay to do it now. Well, I'm sure that both of you know both of you, most of you know from watching previous videos that the equation with the red dot and the equation with the blue dot are going to be parallel, right? How do we know that? They have the same slope. Parallel lines have the same slope. And so I'm going to graph those really quick. Let's see, the slope or the y-intercept of the first one is -5, 3, 4, 5 right there. And the slope is rise 2, run 1, 2, 3. Rise 2, 1, 2, 3. Okay. And so I'm going to go ahead and graph that line. Where are my lines? Lines, where are my lines? I found them. Okay, so there is my line, and I'll make it red and maybe a little bit thinner. There we go. That looks pretty decent. And let's do the other one. Just a quick review, up to on the y-intercept, and the slope is 2/3. 1, 2, 1, 2, 3. All right, so I'm getting ready to draw that line. Go down to back 1, 2, 3. And there you go. And they should look very much parallel to each other. They might look a little bit off because of human error or machine error, but they should look like they're never going to intersect. Now, a cool thing is, later on when you get higher math, like beyond calculus, you'll start to learn about models where parallel lines can intersect, and it's actually kind of cool. But in this class and all of your high school classes, no parallel lines will ever intersect. If you're wondering about it, just think we don't live in flat land, okay? We live in a three-dimensional world, and so therefore lines aren't actually straight in the way we think they are on a graph paper, okay? But for this class, they are straight. Okay, here's another one. Now these do not have the same slope. Let's see what happens with them. They're both written in slope-intercept form. So let's see, the intercept is, y-intercept is 2, and the slope is -4 over 1, and let's go up 1, 2, 3, 4, and back 1. There we go. So I get a nice little line like this. 2, 3, 4 over 1. So it's going to do something like that. And I want to make him a little bit thinner. Because it feels like, the past two videos, I made them back to back. It feels like it's been a long, long time since I've made a video for you guys. I just, with all the snow days, I've gotten way ahead and haven't had to do much. But let's get back in the groove. All right. So the second one has a y-intercept of -3. So 1, 2, 3. Right? And a slope of 1/4. 1, 2, 3, 4. Gonna go back 1, 1, 2, 3, 4. And some of you might be wondering what I'm doing. Just sit tight. I know I haven't told you yet. It's okay that you don't know. 1, 2, 3, 4. Some of you are gonna figure it out pretty quick here. Let me see. Let's do that. There we go. So take a look at the intersection of those two lines. What do they look like? Well, they sure look like they're parallel, don't they? Or perpendicular, don't they? And they are. They are perpendicular. I knew they were perpendicular to start with. How did I know? Well, you see their slopes? First one had a slope of -4 over 1. The other one had a slope of positive, oops, positive 1/4. Perpendicular lines, by the way, that's the symbol for perpendicular lines. It's upside down T. Perpendicular lines have slopes that are negative reciprocals of each other. Yeah, they're negative reciprocals, which means you have to flip the fraction and change the sign. They're negative reciprocals of each other. Okay, so that's perpendicular lines. Parallel lines have the same slope. Perpendicular lines have slopes that are negative reciprocals. Well, how might we use that? Well, here we have a problem where it says find the equations of the lines that are parallel and perpendicular to the line whose equation is y equals 2x minus 5 and that pass through the point 6, 4. Well, normally we're not going to be graphing these, but for the demonstration, for helping you understand, I will graph this one. I got a y-intercept of negative 5, 1, 2, 3, 4, 5. And my slope is 2 over 1, 1, 2, 1, 1, 2, 1. Okay, and so we are going to, okay, draw this line in here. And there we go. Okay, so this is the original line. This is the line y equals 2x minus 5. And I need the point 6, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. All right. Now I need a line parallel to it and a line perpendicular to it. Now I'm going to find these without graphing, but once I get their equations, then I'll go ahead and graph them, and you'll see they do go through this point. And in fact, they one will be parallel and the other will be perpendicular. I'm going to do the parallel one first. By the way, I'm going to change the color of that point. Hopefully you can still see that. That way it'll kind of stand out. Okay, first thing I'm going to do is I'm going to find the parallel one. By the way, this is the symbol for parallel. Okay, so I'm going to find the original slope. Well, that's 2, or 2 over 1. The parallel slope, that's not M11, that's M, the parallel slope, is still 2 over 1, right? So I've got my slope. Good deal. Now, I'm going to go back to the y equals mx plus b equation. I need to write a new equation of a line parallel to this black line. Well, I know the slope of that equation is 2. If I only knew a y and an x, I could fill them in and then solve for b. This should look really familiar. We did some of this way back, I don't know, late November. And so this is x and this is y. So I'm going to fill these values in for x and y. So I'm going to put a 4 in y's place, put a 6 in the place of x, and I'm going to solve for b. So 4 is going to equal 12 plus b. So then b must equal negative 8. The equation of the line parallel will be y equals 2x minus 8. Okay, so let's go down here to negative 8. 1, 2, oh, I'm sorry, 10, 9, 8. There we go. And let's just do our rise and run and see if we hit that pink point up there. So it's a rise 2, run 1, 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 and look at that, it's going to hit right there. Perfect. So in fact, that is the line parallel to the original line. Okay, and I just used a skill that we learned a long time ago about how to write a linear equation when given a slope and a point. I got the slope from the problem, from the original equation, and then I got the y-intercept by plugging in the x-coordinate and the y-coordinate. I keep missing the arrowhead. I keep making the mistake over and over. I'm aware that I'm making it. because I'm not realizing what I'm doing wrong. There we go, that one works. Okay, so that's the first part. The second part is to do the perpendicular part. Okay, so now I got to do the perpendicular part. Upside down t is the symbol for perpendicular. Remember, my original slope was 1/2, right? Oh, no, it's 2/1, excuse me. Okay, it's 2/1. The perpendicular slope, the slope perpendicular, will be the negative reciprocal. So now I know the slope of the second equation. So I take my slope-intercept form, y equals mx plus b, and I'm going to substitute in everything I can. I know that y is 4. I know that m is negative 1/2. I know that x is 6. Where did I get 4 and 6 from? Back here at the original point. That pink point I plotted, plus b. This will help me find the y-intercept. So negative 1/2 times 6 is going to be a negative 3 plus b. I'm going to add 3 to both sides, and I will know that b equals 7. So my equation of my perpendicular line will be y equals negative 1/2 x plus 7. All right, so let's graph it and make sure it looks perpendicular. Now, by the way, it will look perpendicular to both the black and red line, right? Because they're parallel to each other. So 987 is going to be right there. And my slope is negative 1 over 2. Negative 1 over 2. Negative 1 over 2. Look at that. I just hit that line right there. Negative 1 over 2. And let's draw our line. That's a mistake. I guess I can use it. Go like that. Boom. And it sure looks perpendicular. Of course, I'll put the arrowhead on because I've shown you how important that is. You know, part of me wants to say, it's no big deal. They know it. But I'm going to model it for you so that you know it's important. Sure enough, I have a 90-degree angle. It's pretty easy stuff. It's a little bit involved, but it's not difficult. All right, let's try it again. This time the equation is written in slope or in standard form. So let's get my slope right away. The original slope is going to be 2/3, I believe. Negative a over b. A would be negative 2. B would be, excuse me, a is 2. The negative of a is negative 2. B is negative 3. Negative 2 over negative 3 simplifies to 2/3. Okay, so let's do the parallel one. So I know my slope parallel will be 2/3. I use y equals mx plus b. I'm given the point 3, negative 2. So I substitute negative 2 in for y. 2/3 times 3, substituting m, or 2/3 in for m, and 3 in for x, and then solve plus b. So negative 2 is going to equal 2 plus b. Those 3's cancel, right? And so b is going to equal negative 4. So my parallel equation in slope-intercept form is going to be y equals 2/3 x minus 4. Well, let me go ahead and graph the original equation and the parallel one and make sure they're right. Okay, so let's find the x-intercept. Looks like it's going to be 6. 1, 2, 3, 4, 5, 6. And let's find the y-intercept. Negative 4, I think. So 1, 2, 3, 4. Good. So it looks like it's going up 2/3, right? So we'll rise 2, run 1, 2, 3. There's a third point. I'll jam a little line. 1, 2, 3. There we go. And I'm going to just smack an arrowhead on the end of him. Now, the red one will have a slope of negative 4. 1, 2, 3, 4. Oh, I'm sorry. Did I? Oh, interesting. That's funny. Okay, coincidentally, I actually picked the same line. I didn't even realize it. So the red line is actually going to be the same line. It begs an interesting question. Is it parallel to itself? Well, I guess technically, if you're given two equations, you could argue that it is. Okay. Yeah, that was just a goof on my part. I meant, I randomly picked the point 3, -2, and I ended up picking a point on the original line. No matter, we can still do the math. All right, let's do the perpendicular one. This won't be the same line because the perpendicular slope is going to be -3/2. I'm going to substitute -2 in for y. -3/2 times 3 plus b. So I'm going to get -2, and that's going to equal -9/2, or -4.5, right? Plus b. So I'm going to add 4.5 to each side. So I should get 2.5 for b. So I'm going to go positive 2.5. So 1, 2.5 is going to be pretty close to there. Now my slope is -3/2, so I'm going to go down 1, 2, 3, right? 1, 2, and then 1, 2, 3, 1, 2, and then let me draw this line in. It's going to look like that, and sure enough, they are looking perpendicular, aren't they? Okay, uh, that's it for the actual new learning. Let's recap what we do. Okay, first of all, we find our slope. Then we find our parallel slope if we're finding the equation parallel. And then we use x, y, and m in the slope-intercept form of a linear equation to solve for b. Okay? And then finally we write our equation. When we write our equation, we'll have a y and we'll have an x, and then m and b will actually be some numbers. We don't know what numbers they will be, but there will be some numbers. They don't have to be the same number. When we're doing perpendicular, it's the same exact steps, except we'll find the perpendicular slope. And remember, parallel slopes are the same, but slope and a perpendicular slope, they're the negative reciprocals of each other. Okay, that's it for the video. Mr. Lawrence signing off. Have a good night, everybody.